So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video in which we are literally gonna talk about trigonometry in this video. Like, it's a detailed lecture on trigonometry. Basically, we ain't gonna solve questions here, but we are gonna solve, like, not solve actually, but we're gonna focus on proofs basically here, why this is happening, or why the relation of something sine squared theta plus cosine squared theta is 1, why it is so, or there are a lot of things basically. So if you are an Indian, so I would say it is gonna consist of from a very basic things like what is a right triangle, to a high level that is double angle, triple angle, of sine function or cosine function. So yeah, we are just gonna take a look at those things in this video. So yeah, I think it's gonna be a quite long, so you just have to be patient for that, right? And again, if you want to learn trigonometry, so you have to give time to me. And yeah, now it's time to just begin our journey. Okay, basically let me just write down the trigonometry once again. So trigonometry, right? So in this word, if I would request you to focus on these three words, so it's try. It means basically we are gonna take a look at a triangle which has three sides. Oh, I'm sorry. Every triangle has three sides. Oh, what the hell? But actually, we are gonna take a look at the triangle which has right angle triangle. You can just see right over here. This is a right triangle triangle. So basically, this is a right angle triangle, right? So what is a right angle triangle? Angle Right angle basically means pi over 2 or 90 degree. So a triangle which consists of a 90 degree in it, so it is a right angle triangle, right? And this is known as the right angle triangle because this is consisting of a right angle that is 90 degree. So right angle triangle, right? Yeah. And basically trigonometry is all about, there are six functions in trigonometry which deals with the ratios of these three sides, right? So firstly, let's just name them. So let me just take this as a triangle of ABC, right? So in a right angle triangle, basically this biggest side, this one AB, is known as hypotenuse, right? And we would be just representing that side with H. And if we consider this side, that is AC, so it is called base. Because you know what, why it is called base? Because take a look at this. Let's say this is something called height, but and this is base. And you know what base is? The angle, let's say this angle theta, right? So this angle is making angle with the hypotenuse and this side, so we would be consider this as base. And if we talk about this angle, let's say alpha, so for this angle, this would be base and this would be hypotenuse and this would be your height, right? So base and height are gonna change with the change of angles. Like yeah, I'll tell you about that. I will talk about it later, don't worry. So AC is your base, which would be denoted with B. And if we talk about your ABC actually, so BC side is called perpendicular because this is the side which is consisting of a 90-degree angle with the base, so it would be denoted with P, right? Okay, so first of all, I'll be focusing on all things to be proven. What we are gonna do in this video, what we are gonna talk about in this video. But the one thing that I cannot prove in this video is this thing. And I would request you to just memorize this. And if you want a proof of this as well, so you can just comment me down, or else I'll bring a video on the proof of this thing. That is Pythagoras theorem. Wait a second. Yeah. So basically what this says is, if you have something, a triangle, something like this, so if it's your base, it's your hypotenuse, and it's your perpendicular, so the relation between these three sides is h squared equals p squared plus b squared. So this is your Pythagoras theorem is all about, and this is really extremely important. I would say this is one of those equations which are really beautiful, and obviously after the Euler's identity, that is e to the I pi equals -1, or e to the I pi plus 1 equals 0. So yeah, but still that it's one of ancient identities which are really useful, right? Okay, so yeah, this relation is gonna help us a lot in the proofs, right? Okay, so now let's talk about this triangle again. Let's talk about the ratios of them. So let me just use this page, and oh wait a second, here it is. So this is your triangle, right? Now again, I'm just gonna name it A B C, and we would consider this side as h, hypotenuse, and this would be B, and this would be P, perpendicular, and this one was base, right? This one was base, perpendicular, and hypotenuse, right? So basically we are gonna talk about the ratios of these three sides, right? So first things first, I'm sorry, if we talk about this theta, right, this angle, so for this angle, hypotenuse would be constant, like it would be changed, it won't be changed. If we consider this angle or this angle, right, hypotenuse wouldn't be changed. But for this angle, the side which is just attached, or maybe stick with this angle along with the hypotenuse, is known as base, right? And if we talk about this angle, let's say alpha, so the side which is attached or stick to it with along with the hypotenuse, that is this one, is base, right? For this alpha, p is base, right? And for this theta, b is base, so it's gonna be changed. And for theta, this is going to be perpendicular. This side which is exactly in front of the theta angle is known as perpendicular. And if we talk about alpha, so for this angle, the side which is exactly in front of the alpha, this angle is perpendicular, that is B. So I hope you all are clear with that, and that's extremely important, I would say. So first function is sine theta. Sine theta is perpendicular, that is P over hypotenuse. It's a ratio, so it's P over H. And basically I would say side which is in front of theta over hypotenuse, because hypotenuse isn't gonna change, right? So this was your first. I think I should just write this down a little bit here, and yeah, so this was your sine theta. And again, I would like to just cover it in a bracket because it's extremely important. So yeah, this is your most basic thing, and I'm talking about this triangle, so you gotta be careful about that. Now the second thing, cosine theta. So it is B over H. That means the side which is attached or maybe stick to theta along with hypotenuse over hypotenuse, right? As I just explained you, that this theta, like this side which is attached to this theta, this side like AC, right? So over H, hypotenuse, right? So yeah, I think you're clear with that. and again it should be covered in something like this. And now basically these two are very important. Basically with the help of these tools we are gonna take a look at all four identities which are left. Now we have the third one, that is tangent theta, that means tan theta. So for this it's basically sine theta, it's the ratio of sine theta over cosine theta, that's it. So we had sine theta as p over h over b over h, right? So basically it's p over b into h over h, which comes out to be p over b. So basically it's tan theta, you can also say it that it's the side which is exactly in front of theta over side which sticks with theta, along with hypotenuse, right? So that was the definition I would say for tangent theta. It's not, although it's not a bookish definition, it's a definition just made by me right now, along with hypotenuse. So it's just hypotenuse. I'm just writing this to just make you understand. And you know what, basic things are really important. We always use trigonometry to like in integrals and infinite products and infinite sums, but we never talked about this in such a foundational way. So I think let's just talk about this. And now the all, like, we have talked about the most important threes, the sine theta, the cosine theta, and the tangent theta, right? And now we are literally gonna, like, it's the third, the all threes which are left now are the reciprocals of these three things, that's it. So basically the fourth one is, oh wait a second, it's the cosecant theta. So cosecant theta is the reciprocal of sine theta. So it's 1 over, sine theta was p over h, so it's p over h, that means h over p. So that's it, right? And if we talk about the fifth one, that is secant theta, sec theta, we usually write this as, so it's the reciprocal of cosine theta, 1 over b over h, that means h over b. Okay, pretty fine. And finally the reciprocal of tangent theta, that means cotangent theta, so it's your sixth one. So cotangent theta is 1 over tangent theta, and it's 1 over p over b. So cotangent theta comes out to be, oh wait a second, actually cotangent theta is also, oh wait a second, since it's the reciprocal of tangent theta, so it's 1 over sine theta over cosine theta as well. So it's cosine theta over sine theta, right? And also it's b over p. So that's it, guys. And yeah, that was really amazing, I would say, and you need to just take care about these things. So let me just zoom out a little bit, and if you want to take a screenshot of this, so you can just proceed with that. I hope you did that. Okay, now again let's talk about this angle. We have talked about this angle, now let's talk about this angle as well. So well, I'm not going to take a lot of time with that, so don't worry about that. So let me just copy it down. Oh yeah, copy, and again on this page paste, right? Okay, now so basically let's just erase this theta here, and let's consider this angle alpha. So for alpha, right? And again I just said you that the side which is exactly in front of this alpha would be considered as perpendicular. It means this AC is perpendicular for this alpha, and BC, which is P, is base, right? So our perspective are going to change here. So firstly sine theta is gonna be, it's the look, let's just come back to the definition. So it's sine side which is in front of theta. So for our case it's alpha, so the side which is in front of alpha is this b, right? So it's b over h. Oh, I made a mistake here, it's not theta, actually it's alpha, right? So yeah, that's how it went. And for cosine alpha it's p over h, right? Because p is now base with respect to alpha. And if we talk about tangent theta, I'm sorry, tangent alpha, so it's sine alpha over cosine alpha, so it's b over h, wait a second, and p over h, so it comes out to be b over p, right? And similarly you can proceed with the rest of trig functions, that is cosecant alpha is gonna be h over p, and your fifth one, that means the secant alpha is gonna be h over p, and your it's sixth one, cotangent alpha is gonna be p over b, I'm sorry. So yeah, exactly, that's it. So it wasn't difficult at all, but I just want you to just take a look at the difference when we just change our perspective if we talk about this angle. But in the last page we talked about this angle as theta, right? Wow, that's amazing. Okay, so okay, so now we are having these things, right? Okay, it's pretty fine. Now do we think something here, do we notice something here? Can we notice something here? Wait a second, look, wait a second. Well, let me just show you an amazing thing here. So just take a look at the value of cosine theta here. Oh, now let's just take a look at take a look at this thing. Sine theta is p over h, right? And for here its cosine alpha is p over h. It means that if we talk about, let's say this angle is theta, so your sine theta is cosine alpha. Whoa, isn't that amazing? Just take a look at their ratios. And if we talk about cosine theta, so it's b over h, and it is same as sine alpha. So here is cosine theta equals sine alpha. Wow. And you need to remember that for some basic questions, right? Wow. So that's really amazing, that's really cool. Okay, and yeah, you can just play around with those things, and that's amazing. Here your cotangent theta is b over p, and here your tangent alpha is b over p. It means your cotangent theta equals tangent alpha. Wow. So yeah, that was really amazing, guys, that was really, or you can basically say, let me just play around with this. So we have cotangent theta equals tangent alpha, right? Let me just take another time once again. Wait a second, b over p, right? Okay, so here your tangent, you know that cotangent theta is 1 over tangent theta, so we can write this as 1 over tangent theta equals tangent alpha. And from here you can say tangent theta times tangent alpha is 1. Oh my goodness, just take a look at this identity. And these two, the angles are the angles of a right angle triangle. And that's true, that's literally true. Let's just take that out. You if you ain't remember that, so just remember that tangent of pi over 3 is square root of 3, or maybe it's 60 degrees, right? And tangent of pi over 6 is 1 over square root of 3. So actually I'm just gonna prove that down, all these three things, so don't worry about that. I'm just gonna all these two things I'm gonna prove in the later of this video, but for now let's just remember that. So we know that we have a right angle triangle. So if this angle is 60 degree and this angle is 90 degree, so it's gonna be 30 degree. It means tangent of 60 degree times tangent of 30 degree. The formula we have got so far, this one, it should be 1. So let's just check that out. It's square root of 3 into 1 over square root of 3, and hence it comes down to be 1. So yeah, this is extremely amazing identity, right? And we never encountered these identities in our school level exams. I think school level, I would say levels. Okay, I'm not like discouraging schools, but still, that's a true thing. And here we are having secant theta as h over b, and h over b is cosecant alpha. So secant theta equals cosecant alpha, right? Wow, that's amazing. Well, actually you can just reach up to here from here itself, so it's not difficult. And yeah, okay, now I think I should just move on from these ratios and let's just talk about something else, right? Okay, so basically we have talked about the ratios so far, and now we are gonna take a look at the proof of these three crazy things. That is the first one, sine squared theta plus cosine squared theta equals 1. The second one is secant squared theta equals 1 plus tangent squared theta. And the third one is cosecant squared theta, oh wait a second, equals 1 plus cotangent squared theta. So basically we are just gonna take a look at the proof of these three identities, and then we would be moving towards the proof of some like trigonometric functions on some specific values. That is, we are going to take a look at the value of sine of 30 degree or sine of 45 degree, cosine of 45 degrees. So yeah, that's gonna be a quite amazing thing. But before that, just let's just prove this down. So again, I would be needing this triangle. I think I have copied that, so yeah, here it is. So firstly, let's just prove down the first one, that is the sine squared theta plus cosine squared theta equals 1. So if we talk about theta, so we know that cosine theta is the angle which is attached to theta, that means b over hypotenuse h. And if we talk about sine theta, so the side which is in front of the angle theta, that means p, so p over h, right? So here we are having these two things. And again, as I just told you to remember this down, that means the Pythagoras theorem, right? I hope you are clear with that. So let me just write that down here as well. So h squared equals p squared plus b squared. So from these three equations, let's just plug this out. So if we square this cosine squared term, and if it squared this, so we're gonna have p squared over h squared plus b squared over h squared equals, we have to prove it to 1, right? Okay, so since the denominator is same here, so it could be written as p squared plus b squared over h squared equals 1. And from here, from this equation, we know that h squared equals p squared plus b squared. It means p squared plus b squared can be written as h squared over h squared, and this comes out to be 1, hence proved, guys. So yeah, that was quite easy to prove. You just need to remember the Pythagoras theorem, and you just have to make sure that these things are clear to you. So we are done with this first identity. Now let's just prove the second and third one as well. So yeah, so the second one is secant squared theta equals 1 plus tangent squared theta. So from the triangle, we can say that secant theta is the reciprocal of the cosine theta. So it's secant theta is 1 over cosine theta. So it's gonna be h over b, right? And if we talk about tangent theta, so tangent theta is sine theta over cosine theta, and it comes out to be a p over b, right? So now if we square them, and again using this formula, so basically for our case, let's consider h squared minus p squared equals b squared. Actually, we just subtracted both sides with p squared in the Pythagoras equation. So here we are having h squared over b squared. If we square them, so it's 1 plus p squared over b squared. So now if we subtract both sides with p squared over b squared in this equation, so it comes out to be h squared over b squared minus p squared over b squared equals 1. And again we are having a same denominator here, so it is being h squared minus p squared over b squared equals 1. And from this equation we know that h squared minus p squared is b squared, and hence b squared over b squared equals 1. Hence proved. Again, just using these ratios and using the Pythagoras theorem, it's pretty easy. It's literally easy. It's not difficult at all. Now let's just talk about the third one. So we know that we have cosecant square theta equals 1 plus cotangent square theta. So cosecant square is basically it's 1 over sine, so it's h squared over p squared equals 1 plus it's b squared over p squared, right? So from here we can say h, oh wait a second, h squared minus, wait a second, b squared over p squared equals 1. And from Pythagoras this comes out to be p squared over p squared equals 1, hence proved. So yeah, that was quite easy, and we are ready to, like, we have done the proof of these two identities. Basically the major part of trigonometric identities of an Indian typical Indian like grade 10th students are learn till here, and they just memorize the values of tangent of 30 or sine of 30, sine of 60 degrees. But we are gonna take a look at the proof of them as well. So basically, let me just I'm sorry guys, let me just make a table here of the trigonometric functions at some specific angles, right? So wait a second guys. So yeah guys, just take a look at this trigonometric triangle. Actually I didn't mean to waste my time in just drawing this, so I just downloaded it and just pasted it over here. So yeah, basically till 10th grade students, till 10th grade students basically just memorize these values. Sine 30 is 1 over 2, sine 45 is 1 over square root of 2, sine 60 of square is square root of 3 over 2. Yeah, right. But it's not the way we should learn mathematics actually. Let's just dive into it. Basically, we are just going to talk about 30 degree, 45 degree and 60 degrees. And 0 degrees and 90 degrees are quite easy actually, and it's quite it's something you can just visualize it, right? You don't need to just do any mathematics for that. You can memorize that by your own, right? So yeah, that's it. So it was the trigonometric table, actually ratio table. Now let's just talk about sine 45 and wait a second, let me just take another page. Yeah, so let's talk about sine 45 degree and cosine 45 degree. So yeah, we are gonna proceed with that here. So for that we have to consider a right angle triangle again here. Let me just take a right angle triangle with this angle should be 45 degree and this is 90, and with this angle some property it's 45 degree as well. Yeah, so let's say that this is your base, this is your perpendicular, this is your hypotenuse, right? So for sine 45 I'm talking about this part. So for this angle it's sine 45 degrees. It's the side which is exactly in front of this, that is P. Yeah, it's P over H actually, right? And like basically I have talked about this angle, but for this angle if we talk about the sine of this angle, so for this angle this is gonna be the perpendicular, that is B. So and another one is that sine 45 degrees equals B over H, right? it means that if these two, like sine 45 and sine 45, are equal, right, it means the ratios are equal as well. So P over H equals B over H. It means that these two things are equal to each other, because H and H are going to cancel out. So for our preference, let's say this is A and this is A as well, and by Pythagoras theorem, H squared equals P squared plus B squared. It means P is A squared plus A squared, right? B is also A, and it's H squared. So it's H squared equals 2A squared. It means H comes out to be A root 2, right? So the value of H is A root 2 here, right? Okay. And now we are finally done with our sine 45 degrees. That is, sine 45 equals any one of these sides we can consider, because they both are equal. So it's A over the hypotenuse, that means A square root of 2. It comes out to be 1 over root 2. So that was literally easy to prove, and it wasn't difficult at all. So yeah, that's how it's done. And again, if we talk about the cosine term, that is cosine of 45 degrees, so that's gonna be giving us the same result, right? Because again, we are just gonna talk about cosine 45 and cosine 45, and again it's gonna be H equals A root 2. And if we consider the ratio of any one of side with the hypotenuse, so that's gonna be 1 over root 2. It means cosine of 45 degrees equals 1 over root 2 as well. And from here we can say, as we know that tangent of like 45 degrees equals sine of 45 degrees over cosine of 45 degrees. So it's 1 over root 2 over 1 over root 2. So it's 1. Hence proved. And you know what? This is really important. Tangent of 45 degrees. Okay. And again, from here you can talk about the rest of the three terms of the functions of trig of their 45 degrees values. So cosecant 45 degree is gonna be the reciprocal of sine 45, that is a square root of 2, and so for secant of 45 degree. And cotangent is gonna be 1. Cotangent of 45 degrees is 1, because the reciprocal is of 1 is 1. And yeah, that was quite easy. But the for the 30 and 60 degrees we have to do a little bit more things, so just get ready for that. So now we are gonna talk about sine 60 degrees, sine 60 degrees, and cosine 60 degrees, and sine 30 degrees, and cosine 30 degrees as well, right? Okay, so for this we have to consider I would say an equilateral triangle. I think this one perfect. Yeah, it's 60 degrees of each. So let me just make it a little bit bigger, and yeah, we are done with this. Now let's consider a straight line with dotted lines here. So we are gonna just drop it down here. That just because it's an angle bisector, so every angle of an equilateral triangle is 60 degrees, right? So it was 60 degrees earlier, but it's bisected in 30 degrees and 30 degrees, right? And this is also 60 degrees. So now let's just name this. And I'm extremely sorry guys if you're having any kind of background like noise, because there are some illiterate people who are always making sounds in my areas. I'm literally sorry about that. So it's A, B, C, right? And let's consider this as D. Okay, so now we know that this is an angle bisector, so this is perpendicular, and also we know that these two sides are gonna be equal. It means AC is gonna be AD plus CD, and AD equals CD as well. So AC is gonna be 2 times of AD, right? We can just say that, right? It's not difficult to just like take a look at those things. Okay, so now let's consider okay, so again it's an equilateral triangle, so all these three sides are equal to each other. It means that, well, let me just write that down here. So we have AC equals 2AD, right? And we have AC equals AB equals, we have BC. So with the help of these three things, these two things, we are gonna prove the rest of the things. Okay. So now let's just take a look at the triangle. So if we consider for this thing, that is sine of 60 degrees, so let's consider sine of 60 degrees. So we know that the angle, sorry, this side which is exactly in front of this angle, that means this one, over the hypotenuse, right? So BD, it's BD over its AC, I'm sorry, AB it is. So it's AB, right? Okay. So we let's just take a look at the relation between this one, this side, and this side, and then we would be proceeding further. Actually, let me just move it a little bit here, and it's pretty good. And let me just move it a little bit here. I hope you are done with that, and let me just cover it in a box so that you don't get confused. And now let's just talk about the relation between the sides of the, like, I'm talking about these things. Okay. So if we consider the Pythagoras theorem here, so it's AD squared, I'm sorry, AB squared, oh I'm little sorry, AB squared equals BD squared plus AD squared, right? Okay. Now we have AD, right? Okay. So AB is equal to AC. From here we can say, right? AB equals AC. So AB can be written as AC squared equals BD squared and plus AD squared, right? Okay. So AC squared, and from this equation AC equals 2AD, right? So it's 2AD squared equals BD squared plus AD squared. So it's gonna be 4AD squared minus AD squared, subtracting both sides with AD squared, and it's BD squared. So BD squared comes out to be 3AD squared, and BD comes out to be it comes out to be AD root 3. Okay, right? So that was something sort of relation between the base and, like, I'm talking about the relation between this thing and these things, like this side, these two sides. We have BD equals AD root 3. So in this equation, in sine 60 degrees, we can say it's square root of 3AD, right? And AB, right? So AB can be written as AC here, right? From this equation, yeah, from this equation. And sine 60 degrees, we have square root of AD over AC. So AC, from this equation, AC is 2 times of AD. So it's 2 times of AD, and AD cancels out, and we are left with the square root of 3 over 2. Wasn't that literally amazing, guys? Literally, that was just a play of coordinate, or maybe no, I'm sorry, it was a play of triangles and some geometry. Wow, that's amazing. That's ridiculously amazing. And similarly, if we talk about cosine of 60 degrees, so let's just talk about that as well. We have cosine of 60 degrees, cosine of 60 degrees. So cosine is AD, like AD over this hypotenuse, right? AD over AB. So it's AD over AB, and AD over AB can be written as AC, and AC was 2 times of AD, and hence we are left with 1 over 2. That means it's AD over 2 times AD, and it comes out to be 1 over 2. Hence cosine of 60 degrees, 1 over 2. Wow, that was too fast. Whoa, wow, that's amazing. And let's talk about this thing again. We are done with sine 60 and cosine 60, and now let's talk about this angle, that is 30 degrees, right? Although we can use the thing that we have done here, yeah, this one, actually this, these three things, but not that. Let's not do that. Let's just play with the thing that we are playing with actually. So yeah, let me just do things here. So if we talk about sine 30, so for this angle, the side which is exactly in front of this, that means AD, right? And AD over this hypotenuse is gonna be sine of 30 degrees. So I think I should just copy that down here as well. Wait a second. Yeah, copy. Right, and here let me just paste it down. Yeah, it's done. Okay. So yeah, so for sine of 30 degrees, it's AD over AB, and we have AB equals AC, and AC was also equals to AD, and hence sine of 30 degrees comes out to be 1 over 2. Wow, like literally, isn't this amazing? And if we similarly, if we talk about, I'm sorry, cosine of 30 degrees, so it's the side which is stick with this angle, that means BD. So BD over its hypotenuse, that means AB. So BD over AB, right? Again, look at this. Sine 60 was BD over AB, and sine 60 came out to be square root of 3 over 2. Hence, we can say cosine of 30 is the square root of 3 over 2. And again, a thing to be noticed here, from you guys, that sine of 90 degree minus theta is cosine theta, and similarly cosine of 90 degree minus theta is sine theta. Extremely important. And we are in grade 11th of a typical Indian education system, right, from now. And yeah, so sine of 90 minus theta is cosine of theta. Just take a look at this. When you plug theta equals 30 degrees, so it's sine of 60 degrees, and here it is 30 degrees. So sine of 60 degrees is 1 over 2 here. Oh, sine of 60 degrees, I'm sorry, sine of 60 degrees is square root of 3 over 2 from here, and cosine of 30 degrees is square root of 3 over 2 as well, right? So again, it's an important identity, I would say, literally important. And these two things are very useful in some trigonometric world, I'm sorry, integral world actually. Wow. So yeah, we are now jumped off of a typical Indian education system of a grade 10th, but now we are in 12th standard, actually sorry, 11th standard, right? Okay, and now I would request you to just tell me at what level you guys got to learn these things, right? Because I would be curious to know about that. Now let's talk about, well, what are left now. I think we are left with some double angle and triple angle formulas. Wow. Okay. So now let's talk about something more beautiful. First of all, uh, from the beginning of the video, I requested you to just memorize, actually, memorize Pythagoras theorem, right? That means hypotenuse squared equals p squared plus b squared. Although I haven't uploaded a proof of this, but if you want, I would make sure to just take a video on this. But I have uploaded a lot of proofs on this thing. That means Euler's formula that says e to the I theta equals cosine of theta plus I sine of theta. Oh my goodness, that is literally, like, I would say, incredible equation. And from this equation we know the e to the I pi plus 1 equals 0 from this equation only. So that how you can understand the importance of this equation. And we have actually I have uploaded two proofs, I think 2 or 3 proofs on this thing, so you can check that out if you want. But now you would think that, Aman, we are playing with trigonometry and why did you introduce this here? So let me just tell you something. Just be patient. We are going to talk about something crazy things. And actually, let me just give you a sock here. Just wait for that. So the sock is, guys, here's my channel, right? And let me just show you something here. Wait a second. So basically, I have uploaded. Wait a second. Where's that? Where's that? Wait a second. I think it's, yeah, here it is actually. And yeah, no, it's not yet. Wait a second. Yeah, here it is. So this video expanding, let me just play this, or let's not play that here, or let's just play that. So here it is. So in this video we have talked about the proof. Wait a second, guys, someone is calling me. I'm so sorry, guys, actually someone just called me and I had to pick that call. Okay, now let's talk about this. So basically in this video I have proved these 4 identities, right, with the help of the Euler's identity, right? Yeah, so this one, right? So yeah, that was literally important, and I would request you to, if you haven't watched that yet, so you have to watch that once. And yeah, now let's come back to our journey. So here it is, right? So we have talked about the proof, right? I'll just paste this link of that video in this description box of this video, don't worry about that. So far we know that sine of a plus b equals sine of a cosine of b plus sine of b cosine of a, right? And sine of a minus b, wait a second, what's wrong? Yeah, sine of a minus b equals sine of a cosine of b minus sine of b cosine of a, right? And cosine of a plus b equals cosine of a cosine of b minus sine of a and sine of b, right? And finally, if we talk about cosine of a minus b here, so it's cosine of a minus b. Actually, we can prove this using some geometrical way, but I don't think that I should introduce those things actually, because if you are a viewer of my channels, a daily viewer, so you know about this thing, right? You guys are familiar with these things. So this thing actually, so it's easy to understand, that's why, right? So cosine of a minus b is cosine of a cosine of b plus sine of a and sine of b. So these 4 identities, equations or formulas we have proven so far. And now let's just using these 2 things, actually using these 4 things, let's talk about something different. So double angle formulas here, or let's just introduce tangent of a plus b as well, right? So let's just talk about that. So tangent of a plus b equals, well, we know that it's the ratio of sine over cosine, right? So it's sine of a plus b over cosine of a plus b. And we have from these 4 formulas, we have sine of a plus b as sine of a cosine of a plus cosine of a, cosine of b actually, and sine of, I'm sorry, so sine of a and cosine of b here, and cosine of a sine of b, cosine of a sine of b over, we have cosine of, wait a second, it's quite getting complicated, cosine of a cosine of b minus sine of a and sine of b. Okay, so yeah, we are having these things. It's good, right? And yeah, okay, now let's do some manipulations here actually. So let's divide the denominator and numerator with cosine of a and cosine of b. So basically I'm talking about sine of a cosine of b plus cosine of a sine of b over um cosine of a cosine of b. Let's just divide with that, and over cosine of a cosine of b minus sine of a sine of b over cosine of a cosine of b. Right. So let's just solve this out. So it's sine of a cosine of b over cosine of a cosine of b, right? And this can be written as cosine of a sine of b over cosine of a cosine of b, right? Okay, over this can be written as cosine of a cosine of b over cosine of a cosine of b, that's eventually gonna be 1, minus sine of a sine of b over cosine of a cosine of b. Okay, now let's just cancel something, so that's gonna be 1, right? And this cosine of b cancels out, cosine of a cosine of a cancels out, right? And finally we are left with, well, the sine of a over cosine of a is tangent of a, and this sine of b cosine of b is tangent of b plus tangent of b over, and this is 1 minus, well, that's gonna be tangent of a tangent of b. So here it is, tangent of a tangent of b. Hence your tangent of a plus b equals tangent of a plus tangent of b over 1 minus tangent of a tangent of b. Wow, so that's amazing, and that's pretty useful, I would say, and that's literally useful. It's not pretty, it's literally useful. Okay, now let's talk about something more things. Let's talk about tangent of a minus b as well actually. Well, you can do that, and it's not that difficult actually. So tangent of a minus b is gonna be tangent of a minus tangent of b over, it's 1 plus tangent of a tangent of b actually, that's it. So that's quite easy to evaluate. Exactly, it's the same way that the way we did this one, we can do this one as well. So if you want, you can just do that by your own, and it's exactly the same way you can follow using these two, like the sine of a minus b over cosine of a minus b, that's it, right? Okay, so we are having sine of a plus b, cosine of a plus b, and we are having tangent of a plus b as well. So basically, let me just write that down again. We have sine of a plus b as sine of a cosine of b plus sine of b cosine of a, right? And we have cosine of a plus b as cosine of a cosine of b minus sine of a sine of b. And finally we have tangent of a plus b as tangent of a plus tangent of b over 1 minus tangent of a tangent of b. Okay, so yeah, now let's just talk about the double angles of these three things and the triple angles of these things as well, and they are very useful, right? So for sine of a plus b, let's say a equals b equals theta in all these three cases. So we have sine of theta plus theta, that's gonna be 2 theta, right? So it's sine of 2 theta equals, we have to replace a b with theta, so it's sine theta cosine theta plus cosine theta and sine theta. So that's gonna be 2 sine theta cosine theta. Very useful, very much useful identity. You know what, with the help of this one, I have literally reached up to the Euler's infinite product of sine function. So that was sine of z equals z times the product as n goes from 1 to infinity of 1 minus z squared over n squared pi squared. So just imagine that from this formula we have reached up to here. Actually it wasn't only thing, but that it was mostly right. So again, I have uploaded the proof of that as well, so if you want you can check that out. Again, I'll paste the link of that video as well in the description box of this video. Okay, so yeah, and now if we talk about the third, let's talk about cosine of 2a, cosine of 2 theta. So cosine of 2 theta equals, here we have cosine of a, actually cosine of, wait a second, cosine of theta times cosine of theta minus sine theta times sine theta. So that's gonna be cosine square theta minus sine square theta. So that was the first one, and we know that we have proven here. Let me just go through that. So we have proven that, wait a second, yeah, we have from here we can say sine squared theta is 1 minus cosine squared theta, and cosine squared theta equals 1 minus sine squared theta as well. So let's just use them here, right? So let's just vanish the cosine term first. So it's 1 minus sine squared theta and minus sine squared theta. So that's going to be 1 minus 2 sine squared theta, the second formula for cosine of 2 theta. And if we talk about replacing sine square theta with 1 minus sine square, cosine square theta in this equation, so that's gonna be cosine squared theta minus of 1 minus cosine square theta. So that's gonna be 2 cosine square theta minus 1. This third one, the second one, and the first one. Wow, isn't that amazing? Wow. Okay, now let's talk about the tangent one. So it's tangent of 2 theta equals tangent of theta plus tangent of theta over 1 minus tangent theta tangent theta. That's gonna be 2 tangent theta over 1 minus tangent square theta. Useful and important double angle formula, right? Wow, that's good, that's amazing. And now let's just talk about the triple angle formulas as well. Well, you can just prove prove those things down if you want, but I think, should I do that or should I move to something else? Double angles are enough, I think, but for some exams like JEE, you need to just talk about the triple angles as well, because they don't want their children to live a beautiful life. They want their children to just live a struggleful life. So for that, well, I'm not a JEE exam influencer. Actually, I'm just a simple guy who teaches mathematics and studies mathematics as well. That's it. I'm not an exam promoter here. And yeah, I think it's enough. Now, do we have something else to talk about? Yeah, it's not enough. There are a lot of things which on which we can talk about. There are literally a lot of things. Okay, and yeah, I'm just thinking of something. Wait a second. I think it's quite good and it's quite enough. And well, if we talk about some applications of trigonometry, so we just have to play with these things that you have given some sort of, you have let's say that you are standing right over here, right, and you are just looking at this point, that is the topmost point of this, you can say this is something sort of a building, right? So what's the height of this building? If this angle is theta and this length is, let's say, x, so what's the height of this? So let's say this is x. So if we talk about the tangent of theta, we know that it's h over x. So if you have given theta and x, so you can just take a look at the h, that is x times tangent theta, right? So I think it's pretty good. Oh, did I miss something here in the proof of this one? I think I did miss, because I didn't talk about the tangent of 30 and tangent of 60, but it's not difficult, dude. Well, tangent of 60 is sine of 60 over cosine of 60, right? So sine of 60 was a square root of 3 over 2, right? And square root of 3 over 2 over 1 over 2. So 1 over 2 and 1 over 2 getting cancels out, and we are left with the square root of 3 only. And similarly, if we talk about tangent of 30, so it's sine of 30 over cosine of 30, so it comes out to be 1 over square root of 3. And yeah, I think it's done, and yeah, it was quite good. We have proven this one, 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 this one. And now with taking the reciprocals of sine, you can just talk about the cosecant term, and with the reciprocals of cosine, you can talk about the secant terms, right? And with the reciprocals of tangent, you can talk about the cotangent terms as well. So I think it's enough, guys. It's been 1 hour and 1 minute of 50 seconds, and we did learn a lot of things. And yeah, it's enough, guys. And again, if you got to learn something from this video, please make sure to like, subscribe and share. And if you have any kind of doubt so far, you are free to ask me in the comment section again and again. If you want more in trigonometry, so just comment me down. I'll take a lot of things for you again in the later videos if you want. And yeah, it's fine, guys. Goodbye, take care, love you, and just be careful, because that is unexpected, right? Goodbye, guys, take care, love you, and just stay tuned for the next video. Love you, guys.